Hi there, this is GCSE Physics, and this one's Atomic Structure Lesson 2, and it's Lesson 1, but obviously a lot of practice, nuclear notation practice. So the objectives are to make calculations regarding nuclear notation. It's basically just a big worksheet. I'm going to put it on, you can have a go at it. If you want to do it from the beginning, if you want to attempt it, just pause. I will do a couple of examples, and then I'll continue to go through the rest of the worksheet and explain it all as I go through it. So I'll leave it on this for a moment. If you want to pause and have a go now, please do. And then in a second, I'm going to do a couple of examples. And then if you feel like, oh, I get it now, give it a pause and then finish it off. Okay? And then I'll just do all the answers as well. Right then, so I've got isotope names on the left with mass numbers, so carbon 12, carbon 16, that's the mass. Got elements, atomic number. Atomic number, remember, is the number of protons. Oops, dropped my pen. So atomic number is basically proton number, so they're the same thing, these two. So that's helpful to know. Then the mass number is the total number of protons and neutrons. Number of neutrons is obviously number of neutrons, and number of electrons is obviously the number of electrons. You've got to remember that for atom, these are all atoms, so the number of electrons will be equal to the number of protons. Anyway, let's do a few examples. So the first one, number of protons, well, the atomic number is 6, so the number of protons must also be 6. And the number of neutrons is the mass, which is 12, subtract the number of protons. Because remember, mass number is the total protons and neutrons. So if we do 12 take away 6, that gives us the neutrons, which is 6, so pretty straightforward. So you might need to calculate for some of the bottom ones. So the next one is number of protons. We've got an atomic number of 8, so proton number must be 8. Neutrons would be mass number, subtract atomic number, so 16 take away 8. So there'll be 8 neutrons. So if that kind of makes sense and you want to have a go at it, please do, just pause. And I'm going to carry on now and just go through all the answers. So helium 4, so number of protons, it's got 2 atomic number, so 2 protons. Number of neutrons is mass number minus atomic number, so 4 take away 2 is 2. So next one, number of protons, same as number of atomic number, 12. Number of neutrons would be mass number take away atomic number, so 25 take away 12, which is 13. Next one, same again. So number of protons is the atomic number, so it's 92. And the number of neutrons is 238 minus 92, which is 146 neutrons. So in this one, we've got number of protons and number of neutrons, which is obviously combined, the total mass. So you could just add them together for each one, or you could have spotted that the notation's just got the mass number anyway, so we could just copy that over. So hydrogen 3 has got a mass number of 3, obviously. Lithium would be 6, nitrogen's 14, fluorine's 19, and plutonium is 242. Atomic number is obviously the number of protons. So 1, 3, 7, 9, and 94. So you might be thinking, well, this is relatively easy, but it's very good practice for the, for the meanings of the words. So atomic number is the number of protons, and by drilling that, the aim is obviously when you do your exam, it becomes more second nature, and you won't get anything wrong or get confused. So number of electrons is obviously they're atoms, so the neutral, remember. So the number of electrons will be equal to the number of protons, or the atomic number. So that's 1, 3, 7, 9, and 94. Well, so maybe a little bit trickier, getting less information. So we've got boron 10. So the mass number is 10. Carbon 14, 14. Sulfur 34. Chlorine is 37. Thorium is 234. Number of protons, remember, obviously number of protons is the atomic number, so 5, 6, 16, 17, and 90. Number of neutrons, the number of neutrons is the total mass, subtract the atomic number. So first one, boron 10 is 10 take away 5, which is 5. Then 14 take away 6, which is 8. The next one would be 34 for the mass, take away 16, which is 18. And then the next one, chlorine, will be 37, take away 17, which gives us 20 neutrons. And then 234 take away 90, which is 144 neutrons. And then obviously the number of electrons, they're atoms, so they're neutral, same as the number of protons. So 5, 6, 16, 17, and 90. Next one, so we've got the number of electrons. If we've got the number of electrons, that means we've got the number of protons and the atomic number because they're neutral, so they've got the same amount. So number of protons, let's just write them in. So 2, 6, 8, 11, and 93. And then we've got the same for the atomic number, because obviously the atomic number is the number of protons. You might be fed up of hearing this over by the end of this session, but we need to know it. So that's 93. Right, so mass number. Mass number is obviously here in the notation. So mass number, that's 3, 13, 15, 22, and 240. Then to get the number of neutrons, we obviously need to do the total mass, subtract the atomic or proton number. So 3 take away 2 is 1. 13 take away 6 is 7. Then we've got 15 take away 8, which is 7 again. Then 22 take away 11, which is 11. And then 240 take away 93, which is 147 neutrons. Okay, so next one, a little bit different. So we've got the mass numbers, so we can transfer them over from the notation. So we've got lithium 5, carbon 11, neon 20, sulfur 33, and uranium 235. So we've got the number of neutrons, we've got the mass number, so we can get the number of protons by doing the mass number take away the neutron number. So 5 take away 2 is 3, 11 take away 5, 6, 20 take away 10 gives us 10 protons, sulfur 33, so we've got to do the mass 33 minus 17, which will be 16, and then finally uranium 235 minus the 143 neutrons, which is 92 protons. Atomic number is the number of protons, so we can write them in. So 3, 6, 10, 16, 92. And then the number of electrons, obviously the neutral. So the number of electrons will equal the number of protons, or the atomic number is obviously the same, as I've told you 27,000 times. So I guess you best remember it. And 92. Right, hopefully you got all that right first time. If you didn't and struggled at the beginning, hopefully you started to pick up towards the end. If you need to redo it, feel free to rewind and have a go at it again. Okay, I hope that's helpful. That should be enough practice for that type of thing. And like I said before, that'll help you in physics and in chemistry at GCSE. So thanks for watching, and I'll see you at the next one.